But of course, we must find a sustainable means of generating energy as well. And I think that the most likely, well, the main candidate for energy generation is actually solar. I think the physics of this is actually rather obvious because the Earth is actually almost entirely solar powered today as it is. It would be a frozen ice ball at, I don't know, 3 or 4 Kelvin if it weren't for the sun. And our entire system of precipitation is powered by the sun. The ecosystem is almost entirely 99.999% powered by the sun, except for some chemotrophs at the bottom of the ocean. That's it's rather obvious that I think one should try to take a little portion of that energy, and it's actually not much, and convert that into electricity for use by society. So I'm quite confident that solar power will be the single largest source of energy, or electrical energy, for humanity in the future. It will be combined with other things, of course, such as hydropower and geothermal, and I actually think nuclear is not a terrible option, as long as you're not located in a place that's susceptible to natural disasters. That's also, I think, defies common sense. But so as long as there aren't huge earthquakes or sort of weather systems that have names coming at you, then I think nuclear can be a sensible option. And there are much safer and better ways of generating nuclear energy, I'm talking fission here, than existed in the past when nuclear reactors first came out. And then at some point in the future, it'd be nice to make fusion work. Of course, that would be quite good. But in the meantime, I think indirect fusion, being solar power, is a good thing to do. And
so there's a certain amount of carbon that is circulating through the environment. So it's going into the air, being absorbed by, and then getting absorbed by plants and animals, and then going back into the air. And this carbon is just circulating on the surface. And this is fine, and it's been doing that for millions, hundreds of millions of years. The thing that's changed is that we've added something to the mix. So this is what I would call the sort of the turd in the punch bowl. So we added all this extra carbon to the carbon cycle, and the net result is that the carbon in the ocean's atmosphere is growing over time. It's much more than can be absorbed by the ecosystem. It's really quite simple. We're taking billions of tons of carbon that's been buried for hundreds of millions of years and is not part of the carbon cycle, taking it from deep underground and adding it to the carbon cycle. The result is that a steady increase in the carbon in the atmosphere and in the oceans, which doesn't look like much if you look at it on this chart, but when looked at in the context of history, it actually looks like this. So the carbon parts per million has really been bouncing around the 300 level for around 10 million years. And then in the last few hundred years, it went into a vertical climb. This is the essence of the problem. This is very unusual.
I mean, the fundamental issue we have in energy and transport is the tragedy of the commons. We've got the CO2 capacity of the oceans and atmosphere that is unpriced, or mostly unpriced. And so it's almost like we're sort of dumping garbage in the atmosphere, and nobody's paying for garbage collection. So it's a most unfortunate situation, because there are quite significant vested interests in oil, gas, and coal with enormous amounts of money. It's quite a difficult battle to fight, and you can't expect them to simply roll over and commit suicide or something. They will fight it hard, and they have been. And so, unfortunately, it requires fighting hard back, and and creating products in the absence of there being a tax on CO2, creating products that don't rely on the relative economics of using hydrocarbon fuels versus electric cars.
I simply look at the future and say, what is the thing that will actually work? And using a non-renewable resource obviously will not work. So we must find an alternative. And it's worth noting, I'm not sure if people are aware of this, but the world could be powered many times over by solar if you had enough battery capacity to pair with it. Many times, like...
The world? I mean,
Probably
obviously
by-
California, where you're
No.
based, but in Europe? Can
times
you really say that in Europe?
1,000. It's literally true. The amount of energy that reaches the Earth from the sun is staggeringly high. We have this enormous fusion generator in the sky that is lobbing out vast amounts of energy. And I'm talking about just using land area. I mean, it's really amazing. In fact, here's a little tidbit. If you take a nuclear plant and you took its current output and compared that to just taking solar panels and putting solar panels on the area used by the nuclear power plant, because these typically have a big keep-out zone, of about maybe 5 kilometers or thereabouts, where building houses, and dense, any kind of dense office or housing space. Usually, people don't want to do that near a nuclear power plant. So there's quite a big keep-out zone, and when you factor the keep-out zone into account, the solar panels put on that area would typically generate more power than the nuclear power plant.
I think currently what we're doing right now, which is mining and burning trillions of tons of hydrocarbons that used to be buried very deep underground, and now we're sticking them in the atmosphere and running this crazy chemical experiment on the atmosphere. And then you've got the oil and gas companies, which have ungodly amounts of money. And you can't expect them to just roll over and die. Like, they don't do that. So actually what they much prefer to do is spend enormous amounts of money lobbying and running bogus ad campaigns and that kind of thing to preserve their situation. Well, as far as climate change skeptic, I mean, I believe in the scientific method, and one should have a healthy skepticism of things in general, and if you approach things from a scientific standpoint, you always look at things probabilistically, not definitively. And so I think a lot of times, if somebody's a skeptic in the science community, what they're really saying is that they're not sure that it's 100% certain that this is the case. But that's not the point. The point is to look at it from the other side. See, what do you think the percentage chance is of this being catastrophic for some meaningful percentage of the Earth's population? Is it greater than 1%? Is it even 1%? If it is even 1%, why are we running this experiment?
Right,
Because
you called it a Russian roulette. We're playing Russian roulette with the atmosphere.
we're playing Russian roulette, and as each year goes by, we're loading more rounds in the chamber. It's not wise. So that's, and what makes it super insane is that we're going to run out of oil anyway. Like, it's not like there's some infinite oil supply. We're going to run out of it. So we know we have to get to a sustainable means of transportation no matter what. So why even run the experiment?
Right,
It's the world's dumbest experiment.
right.
It's true that in dense cities, rooftop solar is not going to solve the energy need. Yeah. But what you can do is have ground mount solar power, let's say near Hong Kong, tapping into the existing power lines that are coming in. So you can supply Hong Kong with solar power. We just need to be coming from a land area that's not too far away. And I mean, it's worth noting, certainly, China has actually an enormous land area, much of which is hardly occupied at all. Given that the Chinese population is so concentrated along the coast, once you go inland, the population in some cases is remarkably tiny. So you could easily power all of China with solar.
All of China with solar.
Easily, yeah. Yeah, no, easy.
The world's most populous country.
Yep, definitely.